There we go. Okay. Welcome to meeting. Is this 3 for segment 2? Is that right?
I guess so.
Whatever it is, it doesn't matter. Good work this week. Everything looked pretty good. I went through it last night and this morning and cleaned some stuff up, and I think sorted stuff out. Mike, you gave me a call on Wednesday or Thursday, I think. Is that right?
Yeah, Wednesday. Yeah, Wednesday.
So you saw in one of the seminars or one of the recordings or something that we are not permitted to use mains distribution. Is that right?
Right. We should be using DC.
Okay. Not
because it's a safety thing, and so it complicates the system. I mean, you can run your rate off your batteries, or you can run off of the charge thing instead of having to have an inverter and having all these breakers and having a dangerous voltage and all the, it causes a huge level of complexity and safety.
Yeah, going to DC from AC removes the inverter, removes the strict requirement for, really having breakers at all. You probably should. And probably GFCIs, we could probably rethink that one a little bit too with DC, but we'll get into that a little bit later. What were you saying, Zane?
I was saying that we can still have fuses for protection if we go with DC.
Yeah, I wrote that down. Well, actually, let's just get right into it. I haven't looked at the pestle thing yet. That's just kind of all. That's not really that interesting.
I have an issue I have to bring up here too, as well, with that section 2. I was reading it, and when I read it, I was a little worried about it, so I ran it through a plagiarism checker. It's 57% plagiarized.
Okay.
And I went to the sites where where it pointed it out, and it's copy pasted.
Okay, so that means we have to at least cite some sources. Okay, it sounds like it has to be rewritten then. Okay, not a big deal.
Use those as sources, maybe rewrite it.
Yeah,
like I said, it's beginning. It's a good place to find the sources, but we definitely need to cite it, and we probably need to rewrite it so that it's not word for word.
Right. So I haven't looked at it at all. It can probably be 50% curated out, but I don't know that. But I'm just guessing. Much of this is not very important. But, okay, we
can summarize one of those points that are made, and
that's a good. That's a good check. Thank you for checking that, because we would get really burnt by that one. Anyway,
I got the Grammarly app, so I have premium. I can, if we need to run anything through Grammarly, I can do it through that.
Yeah, for sure. Yeah, that's a really good idea. Okay. Let's get into this. So Alexi and Zane, you guys worked on this this last week, is that right?
That's correct, yes.
Okay, I ran through it last night and this morning also. I made quite a few changes. I didn't really change that much. I just kind of restructured it. So I crossed out mains power because Mike told me that we are not allowed to use that. Renewable energy, I'll zoom in. I see you guys squinting, sorry. Renewable energy source with sufficient capability to meet output requirements. DC power distribution with circuit isolation. Circuit isolation meaning that each house can be isolated from the central point, or each node can be isolated from the central point if we're doing a node topology or whatever the topology winds up being. And we don't know that yet. We just got to go on the map and draw it out. Power rating labels for all panels. Overload protection on all circuits. Sure. Maximum voltage 24 volt DC. So we can't do 240 anymore. Since it may not be possible to reliably restrict system access. Might have some people digging around in the junction boxes and stuff. So.
Apparently goats like to chew cables too.
Yeah. Oh, right. Goats. Yeah, that makes sense. Good thought. System inputs must be protected from lightning strikes, because I think that's a monsoon climate, right? But anyways, that's pretty normal. Hot, humid environment. Structural integrity and leak fastness of buildings that are there already is unknown, and we're thinking that, well, since it's unknown, you have to assume that it's bad. IP65. I'm not sure if that's the right choice. We'll have to select the correct IP rating. IP65 would be a very, very safe choice. Enclosures, corrosion-proof conduit, and galvanized everything. Yeah, everything has to be galvanized. Probably painting isn't good enough for this stuff since it's so wet and humid there all the time. Digital inputs. Oh, right. Okay, so this is where I started making a little bit of changes. Digital inputs. I think before it was no protocol message structures required. Right, so I changed it so that, like, I'm thinking digital and analog inputs and outputs to, like signals, right? So using 12 or 24, depending on what system output voltage we choose, seems to be the just obvious choice, right? Match the system output, then you can just use that output directly without any kind of regulation or anything, or conversion. Analogs. So this is where I kind of wasn't sure what to choose. It'll either be 4 to 20 milliamp or 0 to 10 for analog, if there are any analog input signals, right, or output signals. So I just kind of went with my gut and said, if we use 12 volt DC and we use 0 to 10 volt analog, that might cause some confusion when someone goes poking around in the cabinets, right? Because 4 to 20 will only be like a couple, it depends on how long the wire is, I guess, but only a couple volts, if even that, like maybe 100 millivolts, right?
If I may ask, what's the
Oh, I think you're cutting in. No, sorry, Zane. I only caught half of that.
I was just saying, what would the requirement be for the analog input, digital input?
I don't know. I don't know if there's going to be any use for it. There may not be. And
I think the charge controller itself will be monitoring the power condition.
That's right. Yeah, so
everything will be monitored in a local controller. I don't know if we'll have any external measurement devices.
Yeah, so I was thinking about that a little bit this morning too. Like, what approach do we want to take? Do we want to go, like, I mean, doing it all ground up is more fun. Like, doing it, like, getting a PLC, programming it ourselves, and stuff like that. That's more fun. But, I mean, the pre-built things already exist. Like this thing I think you're talking about, right? Like that's what you're talking about. This kind of... Yeah. And this was the first one that I just went on Amazon. Solar battery charger. It was the first one I clicked on, and it literally met all the specs that I came up with. Like, just
everything's pre-built. Like,
yeah,
we have to take cost into consideration, and putting something that's already pre-built, everything's already designed, then it takes the liability off of us as well, so that we don't have to maintain a complex customized system. We have a system that already has a manual and everything for the main person to reference.
Yeah, that's exactly correct. So there may... Oops, I meant to open Word back up. There may not be any... I'm expecting there to be possibly some digital inputs and outputs. I mean, if we might have something, right? But analog, I don't know. I'm kind of doubting it myself. But just in case, which one do we want to go with here? Just in case. We have to pick one of these. Do you guys have any strong preference?
4 to 20 million.
Yeah, that was what I was thinking toward too. Okay, so we'll stick with that. and fault indication panel lights required on distribution panel door. So that might be built into that charge controller display, right? It's very likely that it will be. Software interfaces. Again, we might not need this. We might not need it whatsoever. But just in case. Yeah, go ahead.
Just to reiterate a little bit on this section, that this is the requirement the client would be giving to the contractor in a sense.
Right.
So I feel it's good we just put some points there, whether they get used in the solution later.
Yeah.
It's not necessarily required, but it's just at least we can have something under that section rather than nothing.
That's exactly correct. Because if we just put not required for everything, it makes it look like we came up with the design already, right?
That's correct.
Yeah. So physical layer USB. I don't really know anything about USB protocols. I should probably look into it someday. I
think that we would use the USB protocol over the other one. Simply like you would have, let's say your controller, you plug your USB in, you take a snapshot of the information on there, and then they can send us that information from they'd have to do a city and send it to us, right? Like if we had to, if you have to download a firmware update onto it, you would use USB, right? So USB would be used for updating the firmware and software of the controller and for pulling diagnostic information, right?
Right. Yeah, kind of like thumb driving it, kind of like that. Yeah. These are the ones that I know a little bit about, and I mean I guess also these two. But USB, I know very little about USB. Honestly, I know how it works. I know how to plug a USB cable in, but that's all that I know about it. But that sounds pretty fine. And this might also be the software. This might also be where we define possibly what data types we would want to use if we wanted to use Modbus. Like, are we using what length of integer, and are they signed or unsigned, and what's a word size and stuff like that. So now it's the actually interesting stuff we're getting into. System outputs. So this is what we're producing from this system. Output voltage. It is not permitted to be mains voltage anymore, unfortunately, but maybe fortunately, because it makes it simpler. 12 or 24. Let's, I think, make the decision right now. What are you guys feeling? I am honestly leaning okay, no, I'll let you guys talk it out. What do you guys think?
I would suggest 24 volt. You lower your amperage and lower your wire size.
Yeah.
It's still safe.
Yeah, that's what. Oh, go ahead, Sam. Yep.
Yeah, I agree as well. 24 volt sounds good.
Yeah. I mean, we can potentially have both available, right? But I'm leaning myself more toward 24. Just because, for the reasons that you said, it's the maximum safest voltage, lower amperage, smaller wire, and also compatible with a bunch of other industrial control stuff, right? 12 volt, not so common for industrial control stuff. Unfortunately, 12 volt, like consumer components, are a lot more common. Shouldn't really be a huge problem. Most like passive devices that will work on 12 volt should also work on 24 volt, but we'll kind of maybe have to figure that out. Okay, so it sounds like we're set on 24 volt output. Regulation, we will have to pick kind of what we're willing to accept here. Maybe, 0.5 might be a little easier to manage. Okay, P minimum. Minimum continuous total power output. So this is all of the lights on at once. 255 watts if we're using, I wish that dialog would quit popping up. 8.5 watt bulbs. So those are, I think, 100 watt equivalent. And 800 limit. It doesn't seem like 8.5 watts go up to 800, so we might have to drop this, unless this was a hard requirement in the webinar of some kind.
I think what we would base it on is what would be adequate for reading and ambient light.
Yes.
You want kids to be able to read their textbooks at night or whatever, right?
Yeah, so honestly, even 160 watt equivalent per room would probably be enough. I mean, that's what I have, and I read with that. So it's a little dark, but when you got no other lights on, it's not too bad. Okay, but so that's absolute bare minimum, right? And if we went to 256 watts and we spec'd it this size, the system would trip. So recommended, I honestly just pulled this number out of my ass. I just picked 500 watts because it seems like, well, it's a nice even number. And, it might be 600 watts. It doesn't matter. But I would say that that's probably a good bare minimum. So that gives us a safety factor of 2 on that. Okay, so I don't really know the lingo here. I called it trunk and leaf, like a network, right? I'm sure that there's some other.
Main bus.
Yeah, main bus.
Like bus.
Yeah, bus, like maximum bus bar current. The max would be 42 amps at 12 volts. This is based on the 255 watts. 42 amps at 12 or 21 at 24, which gives us a minimum, and I think we're set on copper, minimum trunk wire gauge of 4 at 12 volts, which is pretty big, or 4 at 12 or 8 at 24. So I think I'm just going to delete this 12 volt stuff because we don't care about that anymore. Oops. Let's just do it right now. No, please delete. Okay, anyways, it's just bugging out. Maximum leaf current. So it's really small, right? It's less than 1 amp. So I think that, I don't know if you can get a 1 amp circuit breaker. That's pretty small. You can get 1 amp fuses. I did find on McMaster, this was the only, oh wait, hang on, we're on 24 volt now. 24 volt. Yeah, so it's the only type they have on McMaster anyway. I didn't really poke around anywhere else. There's other types too, right? Like this is from Automation Direct. It's a single channel, and it's like this one. That kind, right? DIN rail. Electronic, pretty expensive though. Or they have the 8-channel one for circuit breaking. There's some other options. That's surge protection. We don't care about that right now. We can go Chinese. We can go fuse block. Like that's a nice thing.
Inline fuses as well.
Yeah, inline with I saw there was an inline fuse holder. Oh, there they are. Yeah, they could just be inline. And that's, I don't know what would be cheapest here. Probably inline fuse holders would be cheapest. Because you only need 2 per house, right? That's 30, that'd be like $45 from Amazon, right? Or I can go with one of these for the main distribution. So you only need, I guess you need, each circuit, like each branch needs current limiting, right? That's the charge controller, and I think that was it for... right, or these. Right, we could also go with these, like, little cheapy ones. And they're pretty cheap. They're actually about roughly the same price as the fuse holders would be. And then there's no fuse to replace. And also nobody can come along and stick a bigger fuse in, right? So that might be an option too. But that will be part of the design, just to give you guys some ideas about what options there are. Reset. Yeah, I like the mini push button reset also, because it just, you mount it right in the face of the junction box, right under the switch, right? And we don't need big light switches either, since this is all DC. That was another thing I was thinking about. Like, we could use, let's just open another Amazon tab. 12 volt panel mount switch. You know, you could use, you know, like little switches like this, or maybe like these ones I was thinking of, right? I mean, like, honestly, that would work. You know, and it would be waterproof enough for in someone's house. Probably not good enough for outside, though. But, like, you know, people put these in their boats and stuff, and they seem to work fine. So, anyways, let's move on. Just some ideas. Right, so the current is very low. Honestly, this is like way too big for that amount of current. But, like, you guys are electricians. What's the minimum wire size you guys would be, like, comfortable trying to handle? Like, I'm sure that we could power these lights off of, like, headphone wire, right? The current's so low. But I said 18 because it just seems like a natural choice.
You kind of you base your wire size on your actual voltage and current, so
right.
You'd have to just take some of these numbers here and see what our actual wire size should be.
Yeah, like, I know that 18 is, like, I'm pretty sure it's way too big. I think I had to. We don't have to look at that right now. But anyways, that's just a spec that we have to. We got a couple weeks yet. We'll fact check all this stuff yet. That was just my gut feeling. Right. Let's just delete that. Oh no, that's why I can't delete it, because it's the revision history. I see. Daily lighting operational time is 5 hours, 18,000 seconds. Was that 5 hour figure given to us? I think it was. Anyways,
I thought it was 4 hours.
Is it 4 hours?
We'll double check.
Yeah, we'll double check.
You got a bit of time yet to look.
Yeah, we got time to double check this stuff. So it's 18,000 seconds. That gives us an absolute bare minimum. If all the lights are on, which they won't always all be on for the whole 5 hours. But if they're always all on for 5 hours a day, 9 megajoules. And I just picked a number out of my ass, 30 megajoules instead. 9, like, the bare minimum is not enough. So I picked 30 megajoules instead, which gives us that safety factor. That's a pretty good safety factor. And we can just get rid of the 12 amp thing. So we need 350 amp hours at 24 volt DC. Actually, we can't do that. We have to keep that 12 volt thing. So 700 amp hours at 12 volts DC. Just to give you guys a little point of reference, because I didn't know until this morning. This is on Walmart. This is pretty. 100 amp hours is a pretty common size. So we got an AGM lead acid, $200. So we need 7 of those. A gel, 100 amp hour, exact same price, which surprised me. I thought that the gel would be more. The regular price is higher. But, you know, this is the real price, right? If they're selling it for this, that's the real price, right? So AGM and gel, roughly comparable. And then you look at lithium, and it's way more. Way, way more. And that is pretty typical from the other Googling around I did for pricing on these. So I'm thinking probably AGM or gel lead acid is the way to go. What do you guys think?
What's easiest also for them to replace, right? Like, lead acid is cheap, it's common.
Readily available.
Yeah. I've heard that It's like one of the few recycling industries that like extends to the third world. Like it's there's lead acid battery recycling everywhere. It's that common, right? So lead acid is probably the right choice. But that will be part of the design phase. We don't care about that right now. Just give you guys some to open word. So would need roughly 7 of those. And whether we go with 7 or 10, whatever. But I would say 7 would be minimum. Lights individually switched. That's right. All circuits to have overcurrent protection. Right, we kind of talked about that already. Okay, so this is where I wasn't quite sure. Distribution box externally mounted. Yeah, that seems fine. Yeah. Or it could be inside, whatever. Incorporating a earth leakage relay. The circuit breaker part is fine. But the GFCI, what are you guys thinking about that? Do you guys want to stick with the GFCI thing?
That would come out now, I believe, with the 24 volts DC.
Sorry, you think it's, what did you say?
It would be removed now because it was put in with the single phase system, but now it would come out, I believe.
Yeah, that's kind of what I was thinking too. And from what I've found, DC, they're not called GFCIs or RCBOs. They're called something else, which I can't remember what they're called. They are very, very expensive. So I think that we don't need that anymore. And I don't even think it would be feasible.
I think we covered with the fuse on each circuit.
Yeah, that's right.
Straight away.
Yeah, if it's a 1 amp or 3 amp fuse or breaker, that's only like 36 watts, right? So that's probably not going to be able to start much of a fire. Well, not quickly or easily, right?
Too familiar with how the solar DC systems work, but most of the DC systems I work with are all ungrounded.
Yeah, that's right. Yeah, everything.
I'm not really for sure on the ground fault circuit breakers.
Yeah, everything. Like, I mean, the chassis is grounded, but none of the DC's not grounded. Okay, E27 light fittings. I think that's like the medium base fitting. Where did you guys get that from, Zane?
Well, that's a standard that sort of used in Africa.
Okay.
So it's sort of, you can type it in maybe on Google there.
I did actually. I think last night I might have closed that window. Okay, I didn't realize that's what it's called. E27 base bulb. Okay, I'll just have to take your word for it because you know best. I guess you're from there, right? So. I think we use I think we call this medium base, but I'm not sure. It kind of looks different from our bulbs. Anyway, sure, E27. So I'm thinking this will be 2-pin now instead of 3-pin because we don't want the ground. IP65, again, we'll put a question mark beside that because we're not sure quite yet. Plastic light switches, again. Digital outputs should be 24 volts DC. And analog out is 4 to 20. Fault indication panel lights required on distribution panel door. Again, that requirement may be met by this thing, right? Or whichever one we choose. I'm not. My heart's not set on that model or whatever. There's some really nice ones. Like I think Siemens makes some really fancy ones that do everything and give you everything and have a bunch of different I/O options and stuff like that. So there's a big solar industry, right? And again, that's the same thing. Energy to be captured from renewable source. So we haven't said solar anywhere here yet, right? Nowhere here did we say solar yet. And we're not even fully decided on that. We're pretty sure, but we're not fully decided. Converted into DC, not AC, and distributed. Okay, let me turn off, because it's starting to get a little bit hard to read. Oh, can I just turn off? Whatever. You guys can read that. Power usage, data capture, and analysis. So this is what we want to get out of this. This is the data that we want to get out of the system. Power usage, data capture, and analysis. Whether that the controller that we get might do that, we may have to put on an external data logger and some shunts or something like that, but shouldn't be a huge problem. Power generation. What's that, sorry?
Oh, I don't mean to interrupt. I was reading about grounding. A 12-volt system won't need grounding because it's below a certain threshold, but a 24-volt system may actually need grounding, so that's something to consider.
Okay, that's good to know. And do we need GFCI protection? Do you know that?
I don't believe we do, but I can take a look here.
Okay, it's not a huge deal to run like 18.3 wire instead of 18.2, right? So we can just do that. Easy peasy. And
sorry to interrupt.
Oh, no worries. Battery depth discharge / state. I just thought of something when you're saying that. So we want the power usage, so that's out. We want power in. That's in, obviously. We want to see voltage and current on the input and output instantaneously. So we just want the value at this point in time, not the history. And error codes. So the error codes would be things like, I didn't want to tab down, I wanted to tab over. Anyways, it would be things like, we'll come up with them later.
It could be, depending on your software, just high voltage or low voltage.
That's right, yeah.
How your system's running.
So that would be a voltage alarm high.
Yeah, like
voltage alarm low. And that would be on the inputs and outputs, right? So this would be like 1800. That'd be 1800. And then VH 1900 or whatever they are. Yeah, we'll come up.
I think you do need GFCI for each circuit. I think you do.
Okay.
I'll double check. I'll look at my book later. Like I'll go through it in depth. But it's saying that DC circuits on top of a house. This is from my little book here.
That's required. Yeah. Photo. Oh, perfect. Hey, yeah, that's perfect. Okay, well then let's retract our 12 versus 24 decision for right now. We'll just leave that one airborne for the minute, and we'll figure that out later. If GFCI and stuff, if all that protection is needed for 24, that probably pushes us back toward 12. But that's almost arbitrary. Just big.
I'll do some research on it, and I'll present it before the end of the week.
Yeah, awesome. Yeah, if you just want to put in the teams or something, then we can continue on.
Right.
Like after you put it in the teams, then we can just make that decision, and then this week, and then continue from that point, because that's a big decision, right? Battery depth of discharge, state of charge. So that will be probably on the charge controller. Okay, external interface not required. We do not have to integrate the system whatsoever. Possibly this may change. Let's just put a little note here. Internet, possibly internet or cell phone. Possibly. We'll see. Might not be necessary. Ambient temperatures, so it doesn't freeze. So that's good for lead acid batteries, right? Because if they're dead and they freeze, they'll burst. Barometer, well, it's not on top of Mount Everest, so that doesn't really matter. No vibration, that's good. So everything can we can use like Moretz and stuff. Average humidity 83, that is very high. So anything that is not painted or galvanized or chromated or anything like that, or chrome plated, it'll just rust right away. Anything that is steel, at least. Air conditioning, not feasible, and neither is dehumidification. It uses too much power. Fire extinguishers, and I added in baking soda if we use lead acid batteries. Metal enclosures, again, not sure if they'll be the best choice. Since there's so little equipment, maybe just a big plastic enclosure would be better. And if it is metal, it should probably be aluminum or stainless. So metal might be okay. When I see metal, I always think steel, right? So perimeter fence required, probably a good idea. It's probably still a good idea. But if we do go to 12 volt, then it's not required because of a safety issue, right? It's only required to prevent vandalism or theft. So we'll have to maybe make that decision. Okay, let's say this. If it's 24 volt, the fence is necessary. No, that doesn't make sense. No, it's not. It's not. No, that doesn't matter either way, really.
Yeah, because I believe the fence decision was just for the, I guess the area this village is in was just prone to vandalism or theft or people stealing components, and it would still be the case regardless of the system.
Yeah. Okay. So let's keep the fence then. Keep the fence.
A friend of mine, they had a friend who installed a solar system in South America. And they have goats there, and the goats will actually, like, you have to really protect
goats.
The animals.
Right.
They chew the cables, they really do. So
we don't have goats wandering around here, so I always forget about them. We have deer, I guess. Deer don't chew on cables, they just eat.
Oh, we've got to worry about that at the plant. We get raccoons.
Oh, yeah.
Go through the cable tray.
I did, right. Well, I work at a grain terminal, and there's raccoons, but my building's always closed, so I don't worry about it. But yeah, that's right, raccoons. Okay.
Well, like ours, since it's such a large facility, I mean, we have accessible cable trays that are just exposed outside, and
will they get through the armor?
Yeah.
Really? Oh my god.
Yeah.
Holy crap! It must taste good. They've got to put some bittering agent on it or something. Anyway. Galvanized metal piles, yeah, sure. Direct burial, 3-core. What is SWA?
Armored, steel wire armored.
Oh, okay. We call that tech cable. Armored, jacketed. Okay. Oh, and it's steel wire armored. Okay. Well, whether it's steel armor, like I typically see aluminum armor, but anyway. Flexible surface mount, 3-core cable for internal cable. So that is not Romex. It's well, we know what it is. It's just normal house wire, right? That's what you're thinking. That white 14 through. Now this, right? For surface mount inside. Yeah, okay. So we'll do that. And then for that would work pretty much everywhere. Maybe outside we could use for stuff that's above ground, possibly that, right?
Yeah, the ironclad.
Right. No, we don't want that because everything has to be waterproof. We want that outside, right? Probably.
Can you bury that cable?
Yeah. It should be direct burial. You just get the stuff that is direct burial. But you don't need the direct burial above ground. You need the UV stuff above ground, I think. So, anyways. That's just the details.
But I mean, aren't we coming from the potentially coming from
Oh,
the
I only got bits and pieces there, man. Sorry. Try again.
Okay, not a problem. No, it's not a problem for now. I mean, we're not on the design. That's fine.
Yeah, that's right. Yeah, just some ideas, right? I think we're pretty much know where we're going with this. Visibility of alarm lights on distance. That is very smart. I would have never thought of that. Yeah, that's a good one. Because if the guy phones in and he says, hey, the lights aren't working. And you just tell him, okay, go look at the panel. What color of light is blinking, right? Blue, red, green, yellow, whatever. Very smart. I would have never thought of that. Distribution. Okay, types of enclosure mount. Distribution board. Lockable with wall mounting brackets and accessories. I'm going to say metal battery boxes if we're using lead acid are not going to work. They probably have to be plastic. Surface mount, light switch, and circuit. Right. So metal battery box, plastic light switches. Hey, okay, we'll figure that out later. Plastic light switches and plastic light fittings. Okay, what are you guys thinking for... Anyways, that's fine. Let's not get distracted by design details. Distribution board... Oh, EMI screening not applicable. No, it's not required. There's going to be no high-frequency radio or anything stuff emitted by this. Distribution board powder-coated RAL 7004 gray. Zane, do you know something about paint colors? Is that why you... I don't know anything about these paint colors. So.
Yeah.
Okay.
Normally when you get a enclosure manufactured, you do specify the colors.
Okay.
So I just thought, put in a color code there just to give a bit more information.
Perfect. Yeah, I don't know colors. I would just say gray or orange, but yeah, if those are the color codes, it's fine. Light switches and fittings, white plastic finish. Sure, yeah. So actually, no, we have to answer this now because I can't get it out of my mind. Is this what are we thinking for the junction boxes in the houses?
Just put light switch box rather. I think it will come out better. See?
And put in 24 volt or 12 volt or DC here.
Like, are we thinking like just the regular kind of light switch, and are we going to surface mount these or?
I don't know what the structure of the houses are.
Right. I don't think they're going to be stick and frame. They'll probably be like cement or adobe or something. I really don't know.
We went to Google to check the condition of sort of rural dwellings in Sierra Leone.
Yeah.
And they were somewhat stick and thatched in a sense.
Okay, but not dimensional lumber? Was it like kind of rough shod?
Very rough, yes.
Okay, rough. Okay.
Mud and clay.
Okay. So I'm thinking it's going to be like a lot of zip ties and tape putting this equipment in, right? Okay. So there might not be a reliable place to drive screws in uniformly or anything. Okay. So what kind of junction box?
Yeah, see, it's different, the images it brings up on your side to what we had in mind.
This is all North American standard, I think.
Yeah, let's switch to South Africa. Or what is it? Is it just called Africa? No.
Yeah, South Africa was there.
Oh, there it is. Yeah, there it is. I don't think that should make a difference. No.
Or maybe put surface mount. I think we put surface mount at 6 o'clock. Quite a simple.
Yeah. Something like that.
Yes, it was something quite simple like that.
Yeah, sure, that would work. I mean, why do we even have to have a mounted switch? Inline switch. Actually, let's open that in a new tab. Right? You know what I'm saying? Maybe.
Yeah, we could have that.
Like, that's what I'm really thinking. Those are pretty easy. The ground wire can just go around. That doesn't matter. Okay. Got some ideas. Okay, that one's not as complicated as we might think, actually. And it'd be a lot cheaper, too, to use inline switch and a lot easier. Anyway. Functional compliance testing. Functional compliance testing required by manufacturer before shipping and to be shipped with certificate of compliance. Okie dokie. So everything has to be tested before it's sent there. We're in the global era now, so probably you could get something shipped to... probably Amazon would ship to Bow Town. Probably not Bow Village, but probably Bow Town.
Isn't Bow Town like super far away?
No, it's only like 15 minutes.
I must be looking at the wrong area then.
Yeah, we are located. Here, let's look at the. Oh, I'm sorry. I had the wrong. I was thinking of the wrong place. Yes, it is far away. That is Bow Village. That is Bow Town. It's an hour. I was thinking of a different town. I was thinking of Yele. Yele is the close big town, and it's pretty big. All right, I'm not on maps actually.
It's like 50 or 60,000, I think.
I don't know. I don't think it's that big. It looked like it was maybe 5,000 people. Not super huge. Anyways, let's have a closer look at that actually. Oh, actually, we got to pick it up a little bit. We only got 15 minutes here. We'll figure that out. Quality assurance documentation required for all components. Sure. The Amazon crap comes with a little Chinese certificate of compliance, but we might not buy stuff from Amazon. We might buy good stuff. Installation, operation, and maintenance manuals required in English. Is that right, Zane? What language do they speak in Sierra Leone?
We believe it's English, but we can double check.
Okay.
French, isn't it? No.
It might be French. I'm not sure. I'm sure that they speak a couple different languages. Probably like Arabic too, or something. All drawings to be provided in hard copy. Yeah, sure. E27, 10 watts. Yeah, close enough. I said 8.5, but that's close enough. LED lights, surface mount PVC switches. Well, we're kind of rethinking the surface mounting of the switches. It might be inline. Circuit breaker RCBOs. Again, that depends on if it's 12 or 24. 3-core flexible cable and mounting accessories. And the 3-core thing depends on whether it's 12 or 24. Locally trained electrical contractor. Sure, this is pretty simple, so it should be pretty easy. All electrical cabinets to be lockable, fence perimeter. PPE requirements. Well, this actually might be rescinded if it's 12 volt or 24 volt, right? You might not need to wear any PPE to work with that. This is probably not practical. Okay, alternative solutions. Steve also here. Did we look at this yet? No, I don't think so. Solar wind, solar panel to produce small-scale wind turbine generators. Okay, so we can't even think about this. It'll stay there. I'll just stroke it out for now. We can't even think about AC or DC. That's not even a question we can ask, unfortunately. Yeah, so we considered this, but we're pretty sure we're going with. So this is not, we can't even consider it, unfortunately. Customer package. So custom would be like we build the PLC. Well, we don't build it from scratch. We buy it, we put it together, program it, get some voltage regulating stuff, and blah blah blah, all that crap. Or the package is the all-in-one unit, right?
Just a question from the guard.
Yeah.
Is it looking for somewhat three sort of complete solutions? We compared here.
It's looking for 4.
For 4. Oh, Mike's here. I see.
Yeah.
I didn't.
No, I believe per that section it was just three alternative solutions need not be different from each other. So I mean, you can compare it as different, or you can just have different.
Yeah. So like, yeah,
different
this
options of the same thing.
So it's like we have. Okay, well, since we got rid of the AC question, we don't need that question. So we have solar, wind, and steam, right? So those are like where that's where the energy would come from. Solar, wind, steam. So that's 3 times centralized versus individual. That's 2. That's 6 options between those ones, right? Customer package, that's another 2. So that's 12 options we have now. So I think that's okay. That's good enough. And then maybe we could put in for the distribution, like above or below ground. So that would give us like 24 different things.
So that, where does it exactly say where we can't use AC? That Mike
I'm not sure. Mike saw
this. That's in lecture 3. He talks about it. Yeah.
Okay.
He goes through actually quite a detailed guide of what he wants out of this part of the project.
That was in lecture 3. Okay, we'll look at that again.
First part of the lecture.
I'll watch.
Yeah, because that would change the analysis of alternatives as well.
Can you think of any other like real hard constraints that were?
Can we not still use the AC and just obviously weight it down in terms of its safety and usage in this analysis?
Oh, yeah, that's okay. Yeah, that's a good point. Yeah. Good idea.
I mean, this is just a template. It's just a rough draft. I haven't completed it all, and we need group consensus for all the factors and the weights.
That's right.
So that's why it's just a template, and none of this is correct.
Okay, so we didn't get to this last time. I think we had it last time. We didn't look at it. We'll spend another 15 minutes here. We'll go a little over time.
Yeah, we just need to decide on the weights and the scale as well.
Okay, so let's pick the. So I'm seeing 2 tables here. What is each table? What is the top table?
So this is just that has the factors.
The hazards.
And
okay.
Then the factors, and then you've got the weights below. That's just the calculated value. So this is how we did it in the guide, and also so that's how they've done it.
Oh, so it's straight from the guide. Yeah. Okay, so these are the
It's
weights.
in our individual assignment as
Right. Okay. So we're going. Let's pick the weights at least today. So we've got cost, ease of installation, time taken to install, how long it will last, how much maintenance is required, or how much maintenance is required, and how secure it is, or let's call that also maybe safety. Oh no, wait, no. Let's add another column for safety. Insert columns to the right.
Yeah, it doesn't really mention how many factors we can use or should use, so.
Okay, well, safety's a pretty important one. And let's give that one. Okay, so this is, what are we saying? This is from 1 to 5?
Yeah.
Okay, so what is the most important thing here? I'm going to say it's safety. I'm just going to delete all the weights. Okay, is there anything that's as important as safety? I'm going to say no. Safety is the most important thing. What is the next most important thing, would you guys say?
Probably cost.
Yeah.
Probably cost, yeah. We only got 30 grand to work with. And is anything as important or more important than cost that isn't safety? Probably not. Installation. Ease of installation.
Since it's a remote village, I would assume ease of installation would be important.
So we got to think that it's got to be really cheap and it's got to be really easy to put together. Okay.
And to maintain, because once we set it up and they don't have support from us, well, they do. They could call us. But.
Okay. So duration of installation, probably not so important. I'm gonna go ahead. I'm gonna give longevity a 3 because the solar panels themselves, they do have a finite lifespan, as do the batteries, right? And I mean, even things like components in the charge controller, like probably the electrolytic capacitors will eventually just get wrecked, right? So it will eventually just break. So it's not going to last forever. So I'm going to go ahead and give that a 3. Since it's going to be so cheap and it's going to be very safe, I'm going to say that security isn't really that super important. I mean, no one's going to die if someone goes in there, right? So it's just stuff will get stolen or wrecked, but that's not a huge deal. So that kind of makes me think like, oh, maybe we don't need a piece of barbed wire on the top. Oh, hey, there's another one that we weren't sure about exactly. Fence or no fence. There we go. Now let's just add those rows right now. Insert rows below. Fence. No fence.
Yeah, I guess we can get rid of the AC and DC if you'd like as well.
Okay. Sure. Shift cells. Yeah, sure. Oh, that really screwed things up. Okay, we'll just leave it for right now.
Yeah, it's a good.
And duration of installation. So how long it takes to get this thing up and running? I'm going to say probably not very important. It could take like half a year. It doesn't matter. Okay, so those are the weights selected. I think that's a pretty good progress for today, honestly. We decided a lot of stuff today. And so the outstanding questions are, oh, well, hey, let's put that in our table also. 12 volt DC versus 24 volt DC. Right. We'll replace the AC/DC question with that. So we'll call this 12 DC. I'll call this 24 volt. Yeah, right.
One more thing that we should discuss is there anything going on with Aaron?
Right, I keep forgetting.
So I think what we should probably do at this point is offer him one more chance to join us, but we need to contact him through the teacher now. So we need to go to Paul, say, hey, this guy hasn't participated. We want to give him one more chance to participate, but he hasn't been. We need you to contact him for us because we want him to graduate. We want him to do things, but we haven't been able to do it.
Yeah, we can't. We can't just let him fall into the abyss, right? So yeah, we got to reach out to him and try to get him on board here. Because I mean, if he doesn't graduate over something so stupid as not participating in the group project, like that's not acceptable, right? So even if it's just token participation, yes. Would you reach out to him, Mike?
Yeah, I'll reach out to Paul. Say we want him to participate. We're still offering him a chance, but if he doesn't participate in the next couple weeks, then he's AWOL.
Okay, and tell him. Make sure that you say that you had like group approval for, because you don't want to look like you're trying to throw someone under the bus, right?
No, we want him to succeed. But
yes.
That's why we're contacting him this way.
I guess like what I'm saying is you don't want to look like a narc, right? No. That's what I would be worried about, looking like a narc, I guess.
You gotta do what you gotta do.
Yeah, it's just got to be done. It's unfortunate. But anyway, and project risks. You filled out that risk register. Okay, let's quickly look at that. Actually, we'll spend.
It's not filled out yet, but I just want to see what everyone feels. What should we be putting in there at this stage, in terms of risks?
Oops, I think it's back here. Oh, this is just an image. Okay, so I'm just gonna start banging some out that I think risk, electrocution, acid burns, hydrogen. Sorry, I see you guys squinting again. Hey, come on, zoom in.
Dehydration, sunstroke.
Oh, hey, yeah. Right. Hydrogen explosion from, let's say, flooded batteries. Dehydration. Cuts. Sunstroke. Falls? No, probably not falls. Open pits, trips, and no, wait. Whatever. No, that's probably not going to be the case. Like, I mean, what are we thinking? Like, are these risks associated with the installation of the equipment or with its operation? Some of both, yeah, sure. Like, I mean, sunstroke is not a risk for the people who live there. I'm thinking it should probably be more like operational stuff. Well, anyways. Okay, let's just continue. Anyone else just throw words out? I can't think. How about overcharging batteries? Over discharging batteries. Fire in battery bay. Fire in house. Panels damaged by hail. Panels damaged by panels damaged by wind. Water caused short circuits. Did I say theft? Vandalism. Mischief. Kids messing around. Unauthorized tampering or mods. What else?
Not so much just a injury, but transportation issues as far
Right.
as
Okay, transport.
Transportation of goods or
Shipping
deliverables.
Delays or complications. Bad roads. Unreliable. Okay, how about corruption? Bribery. Or interference. Oops. How about equipment? Oops. Equipment not working when delivered. That one's kind of it's mitigable.
How about hiring knowledgeable contractors in the area? I mean,
Right, incompetent contractor. Yeah, that one I wouldn't. I can believe that. Believe me, I can believe it. I've met a few. Oops, I was on our display. Yeah, that's a risk here. Anyway, anything else we can think of? Lightning strike. What if someone's touching their light switch and lightning hits a solar panel? Is it going to kill that person in their house when they're 200 feet away? Gotta think about that, I guess.
Well, you could, instead of kind of getting down to that, you can put as far as installation to code. I mean, because that would nip a lot of that stuff.
Right. Installation not code compliant. And that kind of goes together with this one, right? Incompetent contractor. Batteries. Well, that's more of a maintenance thing. Degrading over time. How about acid fumes in cabinet boxes, etc. Acid burns I had already. Swollen batteries. That would just be lipos only. That kind of goes together with the hydrogen thing. Oh, how about reversed connection or wrong connections? Right, if someone messes with their own wiring and they hook up a black wire where a red wire should go, and hopefully the only thing that happens is the light doesn't come on. But if that's going to wreck something, that's not acceptable. Probably won't happen. Fuses. Oh wait, can't get parts. Anyways, you guys get the idea. These ones are all. That's a pretty good start on these. Anyone think of anything else just off the top of their head? Just blurt it out. We're 10 minutes over time. Okay. Let me see. Minor loss of fidelity. Yeah, that should be fine. Okay, so just to review, today we went through this in pretty good detail. We did a lot today, actually. That was a really good meeting. That was very productive. and went through the alternatives and kind of started figuring that stuff out. Next meeting, we will, let's say next meeting we'll assign weights to this stuff. I'll get some of this stuff cleaned up this week.
I'm sorry, guys. What time you start? It looks like I'm late, and I have four o'clock now.
Oh, did your time change? Daylight savings time, right?
Yeah.
Oh, yeah. That's why.
So you start basically 1 hour early at 3 my time, yeah.
Yeah, our time doesn't change. Oh, I'm so sorry, guys. Saskatchewan time does not change. I didn't think about that. I never have to worry about it, right? So I never think of it. Sorry.
Well, ours, we change, and we don't change till, well, never mind, they're ahead. I'd say tonight. So.
Yeah, I think, like, because we're global, right? I wish that no one observed that stupid crap. It makes no sense to me. Anyways, daylight savings time is so stupid.
So, we have more people in the group. Do we want to bring up our primary issue that Michael talked about?
Let's review again, because you guys just joined. Alexi joined, and Mike Schoenmaker, I think you were a little late. Anyways. Alexi, we did not look at your output here yet, but we're going to have to look at it a little more closely. Did you, by chance, copy and paste it from somewhere?
Basically, when you're speaking about factors, yes, quite a lot.
Okay.
But conclusion, I did myself.
Okay. Oh, and you have
because factors, basically, you'll be copying and pasting that.
Okay.
You know? Yeah.
Yeah, that's probably okay as long as we cite the sources very clearly. Then.
Yeah.
We shouldn't directly plagiarize stuff, but anyways, that's not a huge deal. I'm going to look through this pretty soon. So. Mm-hmm. I've just been putting it off a little bit. Scrolling. Okay, Alexi and Mike Showmaker. Yeah, you guys were a little late. So we started going through the I/O stuff. Right, Alexi, you worked on this with Zane. So we decided we can't use mains power. We're split between whether to use 12 or 24 volt DC distribution. And we're not discussing right now. I'm just reviewing what we're talking about. We're not sure if IP65 is correct. We'll have to kind of review that and check. Digital inputs will be 12 or 24, depending on what we go with. Analog inputs will be 4 to 20 milliamps to avoid confusion with 0 to 10 volt. We're going to use USB if necessary. We may not need to, but if it's necessary, we will use USB, RS-232 with an RS-485 with just the direct wire or the RJ12. Ethernet with the RJ45.
I got to run.
Yeah, go ahead. I'm just reviewing. So, okay, see you next week.
Okay.
Message container will be Modbus, and protocol will be TCP/IP if necessary. Voltage out, we're split between 12 and 24, and we have to figure out what range we want to regulate it to. We're doing 2 8.5 watt bulbs per house for 255, but minimum design power is 500 watts. So that gives us a power safety factor of 2. We figured out the current, we figured out the wire gauge. All this stuff has to be double checked. The light current is less than 1 amp, so that's not too bad. We're not sure if this is 4 or 5 hours. We got to go double check. I'm recommending 9 megajoules. I'm recommending 30 megajoules of power storage, which is about 7 normal size batteries. That gives us a power safety factor of 3.3. All the lights are individually switched, and we don't know if we're going to use surface mount or inline switches yet. All circuits will have overcurrent protection, either a fuse or a breaker. And we looked at some different options of breakers. Watch the recording if you want to see everything. E27 is the light fixture they use in Africa, according to Zane. Whether we go 2 or 3 wire depends on whether we do 12 or 24, because it sounds like...
No, what is wrong? If you using E27, you didn't find it 12 or 24 volts, because or maybe just a car lights.
We might have to go automotive. lights, that's not a huge deal. Like automotive lights would certainly work just fine, right? Okay. So we'll review the E27 thing. If we can find those fixtures, if we can find E27 base 12 or 24 volt bulbs, then it's not a problem, but we might have to change it. And
you get them at check.
Okay, if you're saying we can get them, then it sounds like we can get them. So awesome. Fault indication panel lights required, and they have to be visible from outside of the compound or the building, so through a window or something like that, or maybe they're mounted on the wall outside. That's just a repeat. So we want some data, and these ones I'm thinking might be kind of optional, but we definitely want to be able to see instantaneous input power, input and output voltage and current. We want to generate error codes. This was just an example. That's nothing. We want to be able to see the battery state of discharge, and we want to limit it. The system is probably not going to have an external interface. I'm going to review all this stuff later, so don't worry about it. Nothing's going to freeze. Nothing's going to get shaken to pieces. It's very wet and humid there. We don't know if it has to be IP65. We'll pick the real ratings later, but that's just a recommendation. Air conditioning, dehumidification, not feasible. Fire and spill protection, we need to have some means for protecting against or defeating a fire or cleaning up a spill of acid if we're using lead-acid batteries. Housings and enclosures, metal. Well, probably using steel is not a good idea. So if it was metal, it would have to be aluminum or galvanized, and probably painting isn't good enough. The fence, we require a fence, and all the cabinets must be locked and security fastened. So all the mounts and stuff have to be galvanized. You did that. Direct burial cable, visibility of right. We said that already. I just took the prerogative and changed the metal battery boxes to plastic. You guys pick the colors. That's fine. Don't care. Safety and warning signage required around perimeter fence, right? And we got to figure out what language they got to be in. Function testing. Yeah, we didn't really change anything here. That stuff all looks good. I think I'm just talking to Alexi right now, pretty much.
Yeah.
And we looked through Steve's part of it. We came up with some different alternatives. We assigned the weights. Were you here for that part by then? Alexi, when we were assigning weights?
Weights, I do not know now because weights panel will be about normal solar panel will be about 20 something kilo, 23 kilo.
That's not what I'm talking about. Right. Sorry, I'm talking about the analysis things here. So were you here when we looked at this table?
Sorry, I'm after night shifts. I just wake up, guys.
Oh, no worries. Yeah. So what we did was
till Christmas now.
Yeah, no, I'm bored out too, man. I'm working so much. Anyways, we reordered the importance of the different analysis criteria, and we just said that safety is most important, and then we ordered them in order. And that's all that we did. And then we looked at Zane's risk thing. And I think you were here for that. So that's it. I'm shutting it down. Thank you guys for entertaining my very long presentation.
No, it's all good.
Yeah. So we did a lot of work today. Watch the recording if you got any questions or if you forgot anything. And I'll see you guys next week. Yeah.
Okay, just to comment, the language is English, the official language. So
okay,
that's good.
Okay, we're good on English then. Okay, I'm shutting it down. See you guys next week.
Have a good weekend.
At the okay, let's figure out the time here. I'll just put the time and date link up, and you guys figure out if that's your real time or not. So.
All right.
Okay, so it might be an hour earlier or whatever next week. Okay, see you guys later.
Cheers. Cheers. All right. Bye.
Bye.